Hello friends, now we will see the IC8255 interfacing with 8085 in IO mapping technique. In last video lecture, we have discussed the memory interfacing by using memory mapping technique. Now here we are going to interface the 8255 IC by using IO mapping technique. So suppose the question is interface 8255 PPI to 8085 microprocessor using IO mapped IO scheme with 88 hex starting address of port. Now in this case we are going to use IO mapping technique or IO mapped IO technique to interface 8255 to 8085 microprocessor. So in case of memory interfacing, we have assumed all the address lines A0 to A15 to interface the memory IC or memory device to 8085. But in case of IO mapping technique or IO mapped IO scheme, we are going to use only 8 address lines. That is either A0 to A7 or A8 to A15, because in case of IO map technique the contents you will find on A0 to A7 and A8 to A15 are same, or in short we can say that only 8 address lines we are going to use in this type of interfacing. So the first step, so in IO map IO scheme the address of IO ports is of 8 bits. So the contents on A0 to A7 are same. That is the contents on A0 to A7 equal to A8 to A15. So we can use any one combination for decoder logic. Then as we discussed in 8255 A0 and A1 address lines are used to select the particular port of 8255. So A0 and A1 for port selection we will use, and the remaining lines A2 to A7 or A10 to A15 can be used to generate active low chip select signal. Then the third step, to generate different control signals. Now in this case we are going to generate IO read bar and IO write bar control signals. So to generate these two IO related control signal, we are going to use 3 signals, IO/M bar, read bar and write bar as a input to the 3S2 decoder to generate control signals: IO read bar, IO write bar, memory read bar and memory write bar, where IO read bar and IOW, that is IO write bar signals, are connected to read bar and write bar of 8255 IC. So the signals that we are getting from the 3S2 decoder, that is IO read and IO write, we are going to connect to read bar and write bar. So this is the logic diagram. So here we can able to see the IO/M bar, write bar and read bar are connected to 3S2 decoder, and the outputs of the 3S2 decoder we are going to connect to read bar and write bar of 8255. Now how we are getting the output from 5th and 6th pin? So as we are dealing, or this interfacing is dealing with the IO, so suppose IO write operation is there. Suppose IO write operation is there, so at that time the bit pattern will be So in case of IO device related operation, we know very well this IO slash M bar you will find logic 1. This IO slash M bar you will find logic 1. And as we are discussing about the writing operation, so during the writing operation, this write bar signal goes to logic 0 and read bar to logic 1. So we will get the bit pattern 1, 0 and 1. So 1, 0, 1 means 5. Okay. So as here the bit pattern is 1, 0, 1, the fifth pin gets selected by 3S2 decoder for writing operation. If suppose IO read operation is there, so at that time you will get the bit pattern 1, 1 and 0. 1, 1 and 0. That is CBA pattern you will get 1, 1 and 0 means 6. So 3S2 decoder will select 6th pin. So 6th pin we are going to use for IO read operation. So 6th pin we will connect to read bar. In the fourth step, address decoding table, like memory interfacing, here also you have to write the address lines like A0, A1, A2, A3, A4, A5 and A7, but instead of writing all the 16 number of address lines, you have to write only 8 number of address lines, either A0 to A7 or A8 to A15, because this interfacing is by using IO mapping technique. Okay. So like this you have to draw the decoding table. Then you have to make the nibbles, first nibble and second nibble, that is A0 to A3 second nibble, A4 to A7 first nibble. Then you have to write the address given in the question, that is IO map IO scheme with 88 port address. So this 88 in the binary format you have to write in this particular table. Okay, so 88 port address you have to assume for port A. So 1000 is 8, 1000 again 8, that is 88 hex for port A. Then as A0 and A1 pins are used to select the ports of 8255, the next bit pattern you will get 01. 00 means port A, 01 means port B, 10 means port C and 11 means command word register. Okay, so in this way you have to find next port addresses. So 1000 means 8, 100 and 1 means 89 hex. You will get the next port address for the port B is 89x. Then 100 is 8, 1010 means A. So 8A hex is the port address for port C. Then 100 and 1011 you will get 8B. So this 8B is the port address, is the address for the command word register. Okay, so in the interfacing A0 and A1 or A8 and A9 address line we are going to use for port selection, and remaining lines A2 to A7 or A10 to A15 we will use to generate chip select signal. Okay, so you have to separate A0 and A1 and A2 to A7. A0 and A1 for port selection and A2 to A7 to generate chip select signal by using 3S2 decoder or by using logic gates that we had already discussed in memory interfacing. So this is the connection diagram for the 3S2 decoder. So here A2, A3, A4 address lines we are going to connect to ABC input, A2, A3, A4 as an input to the 3S2 decoder, that is CBA. Then A5, A6, A7 to enable the 3S2 decoder. So here A7 pin is active high, so A7 pin will connect to G1, and A5, A6 both are 0, 0. So A5, A6 we will connect to G2A bar and G2B bar because these two are active low. So as here the input to this 3S2 decoder A2, A3 and A4 is 0, 1, 0. That means the second number pin gets selected by this particular 3S2 decoder. So this second number output from the second number pin we are going to connect to the chip select signal of 8255. The final step, interfacing diagram. So the left hand side you have to draw the 8085 microprocessor. Then this is the demultiplexing logic, AD0 to AD7. Address lines you have to connect to 74373 latch, and from this latch the two address lines A0 and A1 you have to connect to A0 and A1 of 8255 IC, and demultiplexed data lines you have to connect here to D0 to D7 of 8255. This is the hardware diagram for the control signal generation, that is IO read bar and IO write bar. So IO/M bar, write bar and read bar pins of 8085 you have to connect to ABC input, and pin number 5 and 6 are connected to write bar and read bar of 8255. Reset out of 8085 you have to connect directly to reset in of 8255, and finally the chip select signal generation by using 3S2 decoder from pin number 2 is connected to CS bar of 8255, and these are the three ports of 8255: port A, port B and port C. The bidirectional arrow indicates the bidirectional data on PA, PB and PC. Second example, so here we are going to interface a bulb which is working on 230 volt AC 50 Hertz with 40 watt to 8085 using 8255, and also here we are going to write an assembly language program for toggle mode. That means two bulbs you have to interface to 8085 by using 8255. Toggle means the two outputs in toggling mode. And again here we are going to use the IO map IO technique with suitable port addresses. The first three steps are as it is. In IO map IO technique, the contents available on A0 to A7 are same as the contents on A8 to A15. So any one of these two we can use for decoder logic. A0 and A1 we will directly connect to 8255 for port selection, and remaining A2 to A7 or A10 to A15 to generate chip select signal. IO read bar, IO/M bar, read bar and write bar we are going to use to generate IO read bar and IO write bar control signals, where these two control signals we are going to connect to read bar and write bar. And this is the hardware interfacing diagram by using 3S2 decoder or control signal generation diagram for IO read bar and IO write bar. Then address decoding table. So here we are going to assume the port address starting from 88 hex. Okay. So this is the complete address decoding table. So like this you have to draw the decoding table. Address lines A0 to A7, A8 to A15. The port address, you have to write the starting address of the port A, 88 hex 1000 1000, that is 88 hex for port A. Then you have to separate the address lines. So A0 and A1, as we know, for port selection. So according to this, you have to find the next port addresses. So next bit pattern will be 1000 1001. So you will get 89 hex. So 89 hex port address for port B, then 8A for port C, 8B for command word register, A0 and A1 of 8255 for port selection, and remaining lines A2 to A7 or A10 to A15 we will use to generate chip select signal, active low, chip enable or chip select signal. So this is the diagram to generate chip select signal by using 3S2 decoder, where A2, A3, A4 address lines are connected to ABC input, G2 A bar, G2 B bar are connected to A5 and A6, and as the A7 pin is active high, it is directly connected to G1. Next step, so here we have to interface a bulb whose operating voltage is 230 volt AC, but as we know, the 8255 and 8085 is working on 5 volt DC. Okay, so we require a additional separate transistorized circuit interfaced on PC0 and PC1, that is to isolate the low voltage DC and high voltage 230 volt AC. We are going to use the transistorized circuit on PC0 and PC1. So why we are considering here PC0 and PC1? Because on these two pins, by using these two pins, we are going to generate the toggling mode output. Toggling mode means, in the first instance, suppose the bit pattern with PC0 and PC1 is 0, 1, and in the second instance the bit pattern will be 1 and 0. So alternate you should get output from PC0 and PC1, 0, 1, then 1, 0, 0, 1, 1, 0, like this. So toggling kind of output we want from this PC0 and PC1. And the reason behind to take the PC0 and PC1 pin is that the BSR mode, that is bit set reset mode, is applicable only for port C. That's why we have selected port C pins, that is PC0 and PC1. We can use any pin of the port C, PC2, PC3, PC4, 5, PC6, 7, like that. So BSR mode is applicable for the port C, any pin of the port C. So this is the circuit diagram, transistorized circuit diagram, where the transistor and relay is working in coordination with the port C pin status. So here input from the 8255 port C is connected to base of the transistor. So R1, R2, these are the biasing and current limiting resistance, and collector of the transistor is connected to the RC collector resistor, which is connected to plus 12 volt. Then the current flowing through this relay coil relay coil depending on the conduction or active status of the transistor. The transistor will work, or the activeness of the transistor, depending on the logic signal or logic 1 available with the base. If suppose the input from PC0 or PC1 pin is high, so at that time the transistor get turned on. After turn on, the circuit get completed, or the current will flow through this RC resistor, through this coil, and from collector to emitter. And as the current is flowing through the coil, the NC and NO, so here NC means normally closed and NO means normally open. So due to the energization of the coil of the relay, the NC will open and the pole to NO connection get made, and the circuit get completed as the pole is connected to one terminal of the 230 volt AC, and another terminal through this bulb is connected to the AC supply. So here initially it is normally open, that is circuit is not closed, bulb is in off mode. So after the energization of the coil, relay coil, this NO, this NC connection is released by the relay and pole to NO connection is made, and the 230 volt supply flows through this pole to NO and from NO to bulb, and the bulb get turned on. So in this way, depending on the input availability of the input to the transistor get turned on or off. And about this diode is a freewheeling diode, is used to protect the transistor, because due to the current which is available in the coil, there is the chances of the damage of the transistor. So that's why the freewheeling diodes are most of the time found with the relay coils. So this circuit drives the relay to make the bulb on or off depending on the input from port C to the transistor. When the base of the transistor Q is logic 1, the transistor will be on and pass current to the relay coil, which will make the bulb on. And when the base of the transistor Q is logic 0, the transistor will be off and will not pass current to the relay coil, which makes the bulb off. Now we will see the interfacing diagram. So this is the complete interfacing diagram. The interfacing diagram that we have discussed in last slide is the same. So here at the left hand side 8085, this is your 8255 AC. 80 to 87 is connected to latch A0 A1. Address lines are connected to A0 and A1 of 8255. D0 to D7 demultiplexed data bus. ALE signal is connected to latch enable of latch 74373. IO control signal generation logic by using 3H2 decoder, where IO read bar and IO write bar are connected to read bar and write bar. Reset out is connected to reset of 8255. Chip select signal generation by using 3H2 decoder by using A2 to A7 address lines. Then on PC0 and PC1 we are going to interface the transistorized bulb driving circuit. Okay, so here PC0 is connected to the base of the first transistor and PC1 is connected to the base of the second transistor. So in case of toggling mode, initially you will find the PC0 is on, that means the first bulb is in on mode and second bulb in off mode. In the second instance you will find the first bulb in on mode and second one in off, or first bulb in off mode and second bulb in on mode. So in this way you will get the toggling mode of outputs from PC0 and PC1. Then to get the toggling mode kind of output from PC0 and PC1, we are going to write one program for toggling mode. So this is the main program. So here we are going to initialize the stack pointer with FEFF memory address. So LXISP stack pointer with FEFF address, then MVIA 80 hex. So this 80 hex means you have to configure the all ports of 8255 in output mode. So by using IO command word format, we are going to configure the direction of the ports of 8255. So in case of IO command word format, D7 bit is 1 in case of IO mode, and if you want to set the direction in output mode, that is PA, PB and PC, you have to set 0000 everywhere. So according to the bit pattern you will get 80 hex, and this 80 hex you have to send to command word register, and its address is, we have obtained 8B hex. Okay, so this 80 hex you have to load in command word register, and for loading we will take this 80 hex in accumulator, and by using out instruction we will send this 80 hex which is available in accumulator to 8B hex. So 8B hex is the address of the command word register. Okay, so this is the initialization of 8255 in output mode, that is MVIA 80 hex and out 8B hex. Okay, then after initialization of the command word in 8255 in ports of the 8255 in output direction, we will make this PC0 to set and PC1 to reset. Then how to do this? So simply by using VSR mode. Okay, so you suppose the first case PC0 is set, so at that time you will get 01 hex. So 01 hex you have to load in command word register. Okay, so bit pattern will be 00000001. Okay, so 000 means the BBB bits you have to make 0, that is for port C 0, and 1 means set. Okay, so initially you have to set PC 0. Okay, so this bit pattern you have to load in command word register for BSR mode. So take 01 in accumulator and send it to command word register. Again its port address is same, 8B hex. Then in the same time you have to make this PC1 pin 0, that is reset. So load this 02 value obtained by using command word register, that is BSR mode. You have to load in command word, that is 02 you have to send to command word register, that is out 8BX. So in these two cases, in this by using these 4 instructions, we are setting PC0 and we are setting PC1. Okay, then call one delay subroutine such a way that to get the output from the 2 bulbs, that is bulb 1 on and bulb 2 off. Okay, so after sending logic 1, transistor and driver circuit will take some time to glow the bulb. Okay, so sufficient time you have to give such a way that to take the output from the relay driver circuit or from the bulb. That's why here we're going to use one delay. So call delay will call the delay subroutine program. So this is the subroutine program or delay program. So here LXIB, the count value is FFFFX, decrement the BC register pair, move the C register content to accumulator, because by using the DCXB, C register content get decremented first and then B register. So you have to OR the C register content with B register. Okay. So take the C register content in accumulator, just OR with B, then check the 0 flag bit. If it is 0, then come after the loop. If it is not 0, the loop get executed once again. Okay. Okay, so the execution will come out of the loop after getting the count value equal to 0. This return will tell to go back to the main program. So after this call instruction, call delay instruction, next instruction is MVI A00X. So here you have to make PC0 pin reset. Okay, then to make this PC0 reset, the 00X you have to send the command word register. Again use out 8B hex to send 00X to command word register. The next MVI A03X. So here we are going to set this PC1 pin. So take this 03X in accumulator and send it to command word register by using out 8B hex. And after this again you have to call the same delay program. Okay, call delay. So here program execution get transferred to the delay program. Delay get executed, and after the 0 count value, the execution will come out of the loop, and return instruction will tell the 8085 you have to go back to the main program, that is to next instruction. So next instruction is jump up. Okay, so this is the unconditional jump instruction to repeat this toggling mode kind of output infinite time. Okay, so here the outputs of the PC0 and PC1 you will get in infinite mode, that is 0101 kind of output from this PC0 and PC1, and bulb on and off kind of output from this transistorized driver circuits. So in this way you have to interface